Okay, I'm Lenny. I was roped into doing this because I've threatened to do this talk many times. Every time someone talks about not understanding Git, and then Jonathan, he's just left apparently, gave a lightning talk last month on Git, and
We are recording, right? Okay.
and Brian offered me to do this talk. I've given a similar talk at a company that I used to work at. I think at 2 separate companies I used to work at, maybe even 3. It comes from someone else's knowledge, but I've added my own stuff to it. Hopefully people get something out of this. If you're not, ask questions to go deeper. I have a somewhat arbitrary level of depth that I can go into with this stuff, but I'm going to keep it very high level unless people want to ask questions and go deeper. So for everyone familiar with Git, if you were familiar with a previous version control system, you probably know that you needed to forget everything you knew previously. And this is because Linus unfortunately chose to just use verbs that already existed and had meaning for his own uses. This is really annoying. It's gotten a little bit better, and we're going to talk about that very briefly. But when you use Git, probably one of the first things you do is clone your repo. What this means is you have a full local copy of the repository. You have every commit, every branch, every tag, every commit. This is really powerful. If you used previous version control, you probably know why this is so powerful. But let's talk quickly about what are commits. I think I missed a slide here. No? Okay. I think I did, but we're just going to keep going because I don't see it. So commits are actually a snapshot of the entire repository. This is like a branch in other version control systems, right? It has with it some metadata about when this was when the snapshot was created, who created it, and where it came from, which is the hash of the parent, which is yet another copy of the entire repository. It sounds like this would be slow. It's not. It uses a content addressable file system. So the file system itself is based on the content. The hash of that content tells it how to lay out the entire directory. So each hash points to or contains the hash of the previous commit. And so you can walk backwards in time. You can't really walk forwards in time because when you committed something, it doesn't know what you're going to commit next. There are some tools to do that if you ever need to, but hopefully you don't. There's a special case here where there's 2 parents of a given commit, and this is anytime you do a merge. These are special commits called merge commits. They're added to your repository on your behalf. So this commit with an open circle is the merge commit. You see it has 2 parents here. The parents are 7 and 8. Everyone's following so far? Okay. Is this way below everyone or way above everyone? We're doing good? Okay. So there's also branches. These are really, people often use these to reference commits, but all it is a reference. It's a tag. It points at a commit. So it's not a copy of the tree in itself, but it looks like a copy because it just points at one of these commits. So this feature branch here, the feature tag itself is going to point at the last commit in the branch. So here it's going to point at 7. The main branch points at that merge commit, which I don't have an ID on here, but you understand that it also has a hash. So this is, and when we check out, just like the branch tag, a checkout gives us a head tag. The head tag is telling us where in the content addressable file system are we right now. It's just a hash. We can look in the .git directory. There will be a head file. If you cat that file, all it is a hash. In this case, it would be the hash of that merge commit. So every time you do a checkout, you're going to move head. It just changes what's in that file. That's it. And you can check out a branch. When you check out that branch, it changes that head commit to point to the last thing on that branch. Or you can
have the branch name. You have a branch checked out, and it would be the commit if you were detached.
Does
Might
it?
be wrong.
I think it always has a commit
It's
in it.
always the shop.
I think, but we should check that.
Okay.
You can also check out a commit itself by just saying check out and give it the hash. This puts us in a kind of weird state. You may have seen this before. We're in detached head state. It's not scary. People often freak out because it appears as a warning. The warning really should be applied to when you commit on a detached head, because this is where we're getting into dangerous territory. Up until then, we're very safe. When we commit on that detached head, we create a new branch, although this branch is not given a name. And that's going to be important as we go further down here.
It's the fully qualified ref to the branch, so it's like ref / head / branch name.
Okay.
And when you're detached, it'll do the show.
Okay. Thanks. So here, this detached, I just gave it a name for this branch so we can talk about it, but this name doesn't really exist. The head is just the 5 commit here. And now we're in this weird state where if you go back and check out main, that 5 commit is not guaranteed to ever exist into the future. That's where the danger is. And we're going to talk about that more. So that's, okay, so checkout gives us the ability to deal with branches and commits. And so more recently, I think it was added in 2023, there's switch. Now we can say get switch and give it a branch name. This does not accept a hash. This guarantees that you can only ever deal with branches. So it's safe. You're not going to end up committing to committing on a detached head. I see 2 hands.
Checkout, you can also check out like files.
Yeah, that's what I was thinking.
We'll get there. Yeah. Yeah.
That's the reason that I agreed for switch.
Yeah, checkout is
It's
massively over. Checkout and reset are massively over.
Because switch doesn't check out a file.
Yeah. But you can also use restore to do that. So switch and restore have now superseded checkout in most cases, unless you really want to go to a commit instead of a branch. Then if you really want to do that, you can use checkout. But otherwise, if you use switch, you can switch to a branch. If you use restore, you can restore the entire tree, a given file. It has a bunch of capabilities so that you don't have to use checkout, because checkout is this overloaded thing that can do a lot of stuff.
Switch also has dash detach if you want to go to a specific.
Yes, you can force it.
Yeah, you
Mhm.
almost never need checkout unless you're doing something really esoteric.
That's a proper programmer's tool. It's safe, Unless you force it not to.
Yeah.
Yeah, which is the opposite of checkout.
Right.
Checkout's dangerous by default, and
Checkout's nearly
mhm.
hardly this time.
I had no idea. That's what it's doing.
So what we're talking about with some of these things is the difference between the working directory, the staging area, and the repository. So the working directory, everyone is familiar with that. That's where you're editing code. The repository, you're also familiar with that. This is the thing that lives on GitHub or is the actual content addressable file system that is local to you. The staging area is in between there. So when you have something that's modified in your working directory and you want to commit it to the repository, you first add it to the staging area with git add, then you commit it with git commit. So you're moving things along. Of course, with git, it's customizable, and you could do git commit -a, which skips over that does the add for you. And then to go the other way, you can you can move things back into your staging area using reset, and you can move things from the staging area back to your working directory using checkout, or you can also use reset to go all the way back. There's so you can read through the man pages of reset, and there's soft, mixed, and hard. By default, it's mixed. Soft will reset without modifying the things in your working directory, and hard resets everything in your working directory, which again can be dangerous. And this is why restore again exists. Yes.
On that diagram, so some of these git commands will give you messages talking about the index.
Yes.
Is that something on this diagram?
The index is the staging area. Yes, that's the same. Some people call it staging area, some people index. In fact, internally, it's talked about as both sometimes. Yeah.
I've always wondered, where's the stash?
Yeah. I've purposely left that out. I do mention that on a slide later. So stash is a unique thing. It creates a commit that head never references. So it creates a commit, and it holds on to it on sort of this quasi branch thing that's internal. And then when you pop, it destroys it. You can think of it as being destroyed. It actually is still there, and you could still reference it. And it has a hash and all that kind of good stuff about it, but you can't guarantee that it's going to exist into the future. So we're going to talk about that. We're going to talk about garbage collection and coming up.
It's kind of like a detached.
Yes, it is kind of a detached head commit, but it does have a reference until you pop it. So it has a reference, and garbage collection will not garbage collect it because it's on the stash stack. But when you pop it, now it can be immediate. It is immediately available for garbage collection. So this can be dangerous if you expect it to, if you pop it and then reset your, like away from it, now it might not, the thing might not be there anymore because it's eligible for garbage collection. But I hopefully have a diagram that explains this a little better. So after you've been committing, you then push and share your branch with the upstream repository. Now, once you do that, everything needs to be considered immutable, because remember that everyone else is going to be looking at this file system. This is a file system that you're sharing. Someone else can pull that, clone it, and now they can be in trouble. Because if you go and modify it, it's because you treat it like it's not immutable, you do a force push. Now they have content in their file system that doesn't match the content upstream. And now terrible things can happen. Don't do this. No force pushes without really understanding what situations you're going to be in.
I'm nervous about the laughing on the other side. I just want to call that out.
Yeah, it's been real quiet over here, laughing over here.
I've witnessed far too much abuse of that. I've even
Yeah.
performed a little bit of it myself. Oh.
So we have a lot of workflow options when we're thinking about pushing something. Number one, we can preserve our real and dirty history. We're going to talk about each one of these things independently. We could rebase, squash, and then merge our branch. We can rebase, squash, and then move on to feature Z. So let's go into each of these because people have probably heard rebase and they're scared of it. So when we preserve history, this can, this is when we're just going to commit and commit and commit, and then we're just going to push what we've got when we're ready. Now, we hopefully have have someone doing a review. This is hard for them to review because if they want to look at independent commits, they have these useless comments. They have to consider what's going to happen when it interacts with feature Z. But sometimes managers might like this. They can see exactly what you did when you did it. So when you committed going home for the day and you did that at 2 p.m., now the manager knows that you left at 2 p.m. But we're not really, that's not what we're looking to preserve in our history. What we're looking to preserve in our history is the project, not when we went home. So, and before I move on from this, there's something else that's really important here. This is creating permanent technical debt. There are commits here that the commit message says it doesn't work. And so when someone in the future needs to find where a bug got introduced, they can't use git bisect. And if you haven't used git bisect to find a bug, you should, and you will know the pain of this. What git bisect does is you can give it a script to run and a range of commits. So you could say run it from commit feature A to commit feature B, and it does a bisect. And so it's going to probably start on like finally working, and it's going to run your script. If it passes, it's going to then continue to bisect until it finds the first commit where your thing has failed. That script returns a non-zero return code. This is really useful because now you can give it something like a unit test, and it will find where that unit test failed. If you get a bug report from someone and you go and write a new unit test, now you can test it and find exactly where that was. You can go back to your customer and tell them, this is where it was introduced. This is what you need to do. Yes?
Do you know how the bisection algorithm works when the difference between commits includes a nonlinear graph? Like from feature A to B, it's nonlinear. How does it bisect across the different sides of that?
I'm not sure.
No, it does. It handles branches.
It does, it handles branches. I don't know the algorithm.
It'll traverse backwards on first parent, until.
On
it
first
finds-
parent,
Yeah, until
yeah.
it finds the failing commit, and then it will go.
Mhm.
It's handed, but that's roughly.
That's right, and I think you can tell it which parent to choose also.
Oh,
I think
really? I've never
I
done that.
think there's an option to tell it which parent to
That's
choose.
very interesting. I don't know when you'd ever want anything other than first parent.
Yeah. So another thing you can do is rebase and squash. When you do this, you give, and we can go as deep as people want on this. People are familiar with rebase. We can move quickly. People want to talk about rebase and how it works. Yes? Yes? Okay. So you say, when you give it, or you can do an interactive rebase or just a non-interactive. In this case, let's say we did a non-interactive. What we can do is, well, let's go back. Here, we're going to give this, when we're here, we're going to give this an interactive rebase command. So this is like get rebase -I, and we can tell, and say we're working on feature B right now. We're on the fixing CI commit. And we want to clean up our history a bit. We give it our get rebase -I. We tell it all the way back to feature A. Now it's going to open up our editor with a stack of commits that are going to be applied. And each one, we need to tell it what we want to do with it. We can pick it, which means we're going to move forward with exactly that commit. We can edit it. Let's ignore edit for now. We can do a fix up, which means we want to like combine it with the one before it. And we can squash it, which means we also want to combine it with the one before it, but we're going to also be able to edit the commit message that goes along with it. There's also reword, thank you. Yep. And so if we actually want the commit this sucks, but we don't want to push that commit message, we could just reword it, and that gives us the ability to reword that. Now, we might want to collapse these, and while we're doing that, we can reorder them. So we could actually, so here's a bunch of commits. We can do get, is this big enough for people?
Yeah.
Okay. We can get rebase -I, and we're just going to go back a few commits. Oh. Now, we have our 5 commits here. We can reorder them if we want. What's that? Oh, will it? Yeah. Nope. Yeah. But we can.
Oh, because you're in fundamental one
Yeah.
for some reason.
I don't know why. So we can reorder them. We can say we want to fix up this one. When we save and exit, it's going to then apply these in order from top to bottom. So we've just switched the order of the second and third lines, and we're going to squash the third line into the second, which, that's kind of useless that if we also reordered them, but that's fine. But I don't really want to do that.
You're not gonna rewrite your history for us?
Oh, sure, we could. Yeah. Yeah, we could.
You don't actually have.
Yeah, we could just. Yeah, we can remove them. We can comment them out. Same thing. it's going to, it's now going to just apply those that we've picked. So in doing this, we can create commits that have an informative history. You can see that I collapsed that big group of commits that had terrible commit messages into two things that are now kind of sensible and maybe belong in two separate commits there that are logically separate things to do in the repository that don't, they're both part of feature B that's going in, but we don't want them in the same commit, perhaps. This is going to maintain our Git bisectability. It's going, yeah,
I
Jason.
just looked up the Donna man page on Git bisect here, and I think I understand what it's, as far as tracking the parent goes.
Okay.
I think by default, with what you have right here, if you do the Git bisect between A and B, it will take into account engine capabilities and UI for new feature. But if you pass it -- first parent, it would only do feature A, feature Z, feature B.
Oh.
That is my understanding of
It'll
the
essentially
mandate.
tell you the merge. That'll- that
Right, it
solves
says
the problem.
follow only the first parent upon seeing a merge commit. And basically to avoid the problems that you were discussing earlier, seems to be what it's getting at.
Okay, so it's going to walk backwards through, essentially through merge commits.
Just, yeah.
Yep. Okay. So this is also now reviewable. Someone can look at this, and maybe we need two different people to review these things. One person reviews the engine, and another person reviews the UI, for example. But in this one, these were all jumbled together. We don't know who's going to review this. What do they even think is happening here? But this can be really time consuming to squash these commits and create something that is a logical entity. And we lose that work tracking that our manager wanted to know that we left at 2 p.m. Now, we can also, we can still squash these things. And then instead of here where we merged with feature Z, and we sort of created a commit with two parents, we can do this where this isn't really going to have a commit with two parents. This only has one parent. It kind of looks like this from the, it looks like it might have two from this, but we don't have to. We can merge without having a merge commit here, because we could just merge the two commits on the feature B branch in directly. Now, if we constantly, and let's see this in action here. So if we create a new branch and so now we have this new commit on top, right? If we then have,
You did the brand backward.
what's that?
You didn't switch to the new brand?
You're a master now.
Oh, yeah. That's fine. That's fine. Yeah, I know what you mean. Thanks. Let's say we started this out on main. Oh, this is an old repository. So now we're back. So we have this foo2 branch, and we're going to add Um, so now we have two things that diverged, right? We have on main, we have a new commit here. And on this branch, we have a new commit here. If we couldn't just merge this, but if we do a rebase, this is going to now apply foo2 on top of our on top of that first foo. So now we have
Based on the origin master instead of
yeah, thanks. So now we moved that commit on top of the other one. And now we could just push this directly. We don't need a merge commit anymore. But what we've lost is the knowledge of where we were working when we created foo2. So in this one, when we created feature B, we were working, and the whole time we were building on feature A, which might be important to someone doing archaeology in the future. Here, we've lost that knowledge, but we can potentially remove a merge commit. Do people follow this? So there's these two options, and different teams like different things. I'm not saying one's better than the other, but they have different problems. And this can cause a lot of potential rebases, because if you're in a large organization that has lots of things going in, by the time you get your code reviewed and go to merge, you might need to rebase again, which now means you need another of that, and you keep going. So this can be a problem, but it can make a really clean history with no merge commits. So you got to trade that when you think about how you want to make this workflow. Something that comes up regularly with people that don't have a great, that don't really understand how Git is working, is there's this concept of a left and right merge. And this comes from when you draw the tree like this vertically. I've been drawing it horizontally, but if we make it vertical, we can assume that the leftmost branch is main, and we can make branches to the right. If we merge from main into our branch on the right, now when we commit back, we potentially have a lot of merge conflicts, because when feature C came in, that may have had its own set of merge conflicts that got resolved. Now, feature Z gets merged out. It has its set of merge conflicts. Then we're going to merge all of this back in, which creates this like double layer of merge conflicts. So we can avoid this by rebasing if we need to. So we can move our feature B branch that's working. We could, instead of keeping it branched off of feature A, we could move it up to be on top of feature Z, I'm sorry. Yes.
Assuming you've already pushed feature B remotely,
and you're doing rebasing and squashing and these things, are you willing to force push your feature branch, or do you make another branch?
Yeah, so it depends on if it's shared with people or not. If you don't really expect other people to be using this branch, then there's no real problem. You can push it. If other people pull it and they now get weird stuff happening, well, okay. It's sort of your branch to begin with. But if you're working with a group of people, that can be a problem. And maybe you need to coordinate this, or there's also cherry pick. Cherry pick has a different set of issues than merge, but when you later go to merge, it understands that we already have this commit in there and it doesn't merge it twice. But it is now out of order, so that can create some other potential problems. So you just need to know, like, you should just avoid merging out and hopefully avoid this like rebase onto a different feature thing, but sometimes that's not possible. Yeah.
I'll also say, I mean, I agree with this. Speak the word, brother. More than once, I've seen a developer who is constantly merging from main into their branch that have been doing this for weeks. It is
Yeah.
extremely difficult to figure out what they've done. Extremely difficult to figure out what they've done. We suspect, at
is.
least in one case, they were hiding the fact that they weren't actually doing it. But you can't tell, right? Because the only thing you can see is them merging and resolving conflicts. You can't
Yeah.
tell the difference between resolving conflicts and actually doing that.
It sounds like they were doing a lot. They were
Well,
doing a lot of merge
They were
conflicts.
doing a lot of stuff. Thank you.
There are a lot of like UI patterns that encourage this kind of stuff.
There
They say
are.
things like, "You're out of date with the branch. Do you want to
Yeah.
click the
I was
merge
gonna say,
button?"
They-
I place the blame on this one on all the tools that give you a button.
Yeah,
Does this.
GitHub makes this really
Well, GitHub-
pernicious.
GitHub's not alone. GitLab does it too.
I do think that there's good reason to do this sometimes. Like if it's
Yeah.
your standard approach, you're probably doing something wrong. But especially if you're in like an ecosystem that cuts releases, like the Linux kernel is a great example of this, where you've got like your main, and then you do a hotfix directly on the main, and you have a develop branch. The only way that you can resolve that is this pattern.
Or cherry pick or rebase, which have their own sets of
Yeah.
issues.
Cherry pick, you will lose the take. It's fair.
Yes, with cherry pick you do lose some
Rebase,
stuff.
you can also make that engine capabilities commit go from working to not working.
Yes. So there's a big set of work that you have to do if you want to maintain the ability to have every commit working. So yeah,
Or you can just merge right and then fast forward.
if you can fast forward,
Once you merge right, you can't fast forward.
right?
No, like you merge right and then you fast forward left to right.
This is the fabricator pattern. I don't know if anyone else has used fabricator.
Mm-mm.
I'm pretty sure that's exactly what they do.
You fast forward from left to, oh, I see what you're saying, but you're assuming that you want to merge that right away.
Well, you don't have to fast forward it at the time that you merge it, like if it's not done yet, but.
Don't you like if you,
But it's
if you
not
fast forward to the like empty circle commit here, don't you create weird issues around your first parent? Like don't you really, if you're gonna do that, don't you really need two merge commits, one that goes right and then one that goes back left? Which is I think what fabricator actually does precisely.
Well, if you do one that goes right, it's basically the same as merging left, right?
Well, except the ordering of your parents.
Yeah.
If you do a first parent track back through history, you're gonna be zigzagging instead of going.
Yeah, fair. That is fair.
And like first parent tracking back through history is actually like a surprisingly important like topological operation on the Git graph.
Especially with the bisect first. So yeah, you would need to do two merge commits. It adds more commits, but it does keep the commits that work working.
Short-lived branches and rebates always.
That's our rule.
What's that?
Short-lived branches and you always rebates.
Yes, I agree.
There was a remote comment. by the
Oh,
way.
yeah.
William Bowers asked if you, he asked if you were going to talk about force with lease. Force with lease.
I don't know yet. That's force push, but only if upstream hasn't changed.
Oh, okay.
Ah.
No, I'm not gonna cover that.
It's kind of the safe way to force push.
Yeah. But you can also just. So
It's a-
that is going to make
It's a
sure-
way to overwrite your own commits safely.
It's to make sure that no one else pushed something
No one
to
else
that
pushed something.
branch
in between.
in between.
I mean, someone else could sort of pull down the branch and now be off. But they'll find out when they
Yeah,
try.
you can break someone else's repo still, but you can't break the main
I
repo, like
see.
delete
Right.
workout in the main repo.
So when things go really haywire and you need to figure out where did this person go and what did they do? Where were they merging from? In what order? The ref log is the command for you. You can look back. The ref log tracks head. So you can, that head tag that we talked about, as it was moved around, the ref log was updated every time it moved with what it was doing, with a note about what it was doing. So you can see that the first line here is where head currently was in this repository. The next line is where was it 1 change ago, 2 changes ago, 3 changes ago, and so on. And we can check any of these out. They all have hashes. You can even check them out saying head at, curly braces or. So you can move backwards as you go. If you need to look at where this was, did you end up using that?
Not for that case.
No.
I use this a lot when I screw up and all of a sudden I don't understand what the hell I'm looking at. Or I didn't mean to get rid of that branch and I hope it hasn't been garbage collected. Yeah.
Right. That's the concern, is that some things could be garbage collected
Yeah.
if no branch points at them anymore. So that's why I say anything with an asterisk. You can probably get back where you started, but we can't guarantee it.
Isn't the default GC still a month?
Yeah, default is 30 days. You probably, and if you have a lot of activity, maybe you're getting garbage collected every 30 days. If you don't, it's probably a lot longer than that. It has some heuristics, so it'll go a lot longer than 30 days.
It occasionally suggests that you garbage collect too.
Yes, it can offer that.
So detached branches are one of those things that we probably get garbage collected, right?
They are immediately eligible for garbage collection.
And then also stashed sewer branches.
Stashed things that got popped. That commit of the stash is, once it's popped, it can also be garbage collected. It never even had head pointing at it.
Right, that's kind of why I asked, because I didn't know it had ever moved onto that stash.
So I like to avoid stash and pop completely. I would much prefer to make a commit, put it on a branch. I can then give it a name. And it's not going to get garbage collected until I delete that branch and let it get.
I've never used reflog really. Is it like, if you just clone the repo, what does reflog look like?
It's empty.
Yeah.
It's the history of where you've been.
Yeah.
So it's really.
I think it'll have one line.
Check that, doesn't it?
Yeah. Yeah, so it's really useful for when you break things, there's, I've seen people delete their entire repository, reclone it, because they can't figure out what to do. When maybe what they want to do is just look at the ref log and do a reset hard to wherever. And then they will still have all their local branches and everything like that they may otherwise lose. Yeah.
If you run garbage collection manually, does it clear the entire ref log or just part of it?
No, the ref log is just the log of where head was. So it's not going to remove that.
There is a TTL on it though.
There is, yeah. It keeps,
Like under the hood, this is the stash stack with a TTL.
yeah,
So morally, they're nearly identical.
yes. So it does, your ref log isn't infinite, is basically what John's saying. You will lose old stuff in your ref log,
It's fucking long though.
but yeah, it
It's
will be
like-
really
It's
long.
really long. It opens in a pager. I don't know if you've ever hit like Cap G. It's like thousands of what, like it has the head at, like counting backwards. It's a lot.
Yeah.
It's,
Mhm.
Do you know what the time limit is?
I think it's the same as the GC time to live, but I've never had the
I
need to
think
go
it's
more than
90.
like 40 back.
I think it's 90 days.
Is it? Oh wow,
Yeah.
that's pretty, yeah.
So I've noticed on
90.
smaller repos in
You're
mine,
right, 90.
Yeah, sorry, go ahead.
I've noticed on smaller repos, I never notice the garbage collector value, or at least I never get stats messages about it. On big repos, I do. And I was wondering, how can I tune my intuition for when it's going to run? Like, what could possibly trigger it? Are there internal limits that kind of hint
Yeah.
that it maybe should run?
There are heuristics. I've never tried tuning them.
Not that I want to tune it, but I want to like tune my intuition.
Yeah,
Like, is it running, for example, multiple times per day? Is it close to once per
No.
day? I know it's not time-based, but like, I want to get some.
it is
intuition.
time-based, actually.
At least in my case, like, how often? How often running?
So it's time and size based. So whichever thing it hits first, if it's time, it will just garbage collect. If it's size, it will ask you if you want to garbage collect.
It's baked in with the repack operation, right? Like fundamentally, that's what it's doing.
Yep.
Do you get why repacking is needed? Because I think that's kind of like,
So
I don't really understand why.
So because it's a content addressable file system, as the possible locations change, because the total number of commits that you have been to in the past changes, then it needs to remove some of them, because it gets really difficult to find. It gets computationally expensive to find the content that you need. So it just gets really slow. Is there other reasons?
so the primary reason that the repacking happens is because the fastest thing to do when you create a commit is to just put that in its own pack, right? You just have a pack with one commit in it. But then when you need to do a lookup, now you have to traverse a ton of packs, right? And so you end up with this heuristic where it's like the further back you go, the larger the packs get, up to some fixed size. I can't remember, it's like pretty big. And so it's like the more of those small operations you have, the more fragmented it gets, and the more fragmented, like eventually it reaches a certain point of fragmentation. It's like, I have to recompress.
Do you have any slides about what the packs are?
No, it's like really.
There is a question online.
Yeah.
Well, or a comment. Git maintenance will let you tune that in the settings, right?
Oh, okay.
Yeah,
Yeah.
you can turn on the garbage collector.
Yeah, I know all of it is. I've never played with it. Anyone that knows me knows I have really strong opinions.
End of sentence.
Yeah. But I like to try to be open to new things. And I've learned a bunch of new things with respect to commit messages over the years. I've incorporated ones that I like, and I've discarded other ones. And so I'm going to make a few suggestions. They're not going to be for everyone. Definitely not. But let's talk real quick about what a commit message is. So we often think of commit messages as just the title line or the header. So this is a set of recent commits from the NPM repository on GitHub. The first two here have little ellipses after them. That means that if I click on it, it's going to drop down. I'm going to get more information. The author put in more lines, thankfully. The third person did not. Now, I have a question. When I read that, export environment config variable names, which ones? Why? That's not addressed here. Now I have to go and look at the code. I'm potentially going, and maybe I don't know this code. I'm potentially going to spend a lot of time figuring out, is that the commit that I care about? Where the other ones, I hopefully don't have to. I can click the ellipses and it's going to give me some more information. Some things that they did do that I like is they gave it a prefix. So they said the first one was a fix, the second and third were features. Great. This at least, if I'm looking for something specific, I at least have a clue. What I like to do instead is use emoji. This is pretty concise. It's, yes. It's, and when this is used judiciously, it can be really quick to scan things. But like I said, I have strong opinions, and a lot of people really hate this idea.
I'd like a text encoding question, actually. I noticed when you wrote those commits, you used :ART:, which I assume is something that GitHub understands. Have you actually tried using the actual Unicode code points for the emoji instead?
Yeah.
And is that widely supported with all your tools?
It works with a lot of tools, not everything. So
It's a pain in the ass to type.
But
yeah,
Some emoji names are long and they can interfere with the length
Yeah,
of
because
that.
if you,
like
Yes.
construction worker,
it's a single glyph.
It's
You
long.
actually use the Unicode code point for it.
Yeah.
Technologists.
right. But yeah, you have, I think that a lot of tooling wants that title line to be, I forget what it is, 65 characters or short, 72.
Or no, you're right, 65, sorry, 72 for the body.
Yeah, and yeah, 65 is a weird number, but.
Minus the screen width at the time.
Probably written by a telecom person.
this style on the left, oh, sorry, on the left is conventionalcommits.org, right?
Yes. Oh, yeah.
Just use Chinese characters so you don't need to edit coding to.
Is that from Leslie?
Mark, actually.
From Mark.
Can you talk about tense and the tense of the language you use?
Yes, I am going to.
Yep.
Yep, I'm going to. Yes, yes, let's do that.
Passive voice.
So so anyway, I like the emoji. Some people don't. I provided here a list of the emoji that I like. This is the list that I like, and I've used this on projects in the past, and the list has worked well for us. But there are definitely going to be things that maybe your team wants to be creative about. It can be fun. I also like there to be a description of the problem being solved. This is not the solution. This is what the problem is. This says, this is maybe a bug report. This is the details of the bug report. It can be a link to a bug tracker. But here we're not going to talk about what we're doing to solve it. We're just going to talk about what is the problem? What is the issue here? The next thing is the solution that is implemented by the commit. So we can make this as long as we want, really. This metadata can be very long. I don't even know if there's a maximum. But we want to know, so here we now know at this point what we're doing in the header line, what the problem is, and how we solved it. We've covered all 6 questions of problem solving and critical thinking. What we did not do is put how in that commit message. The how is in the code. If anyone wants to know how we did it, just go look at the code. It's available for everyone. If there are particularly questionable things that you're doing that are clever, maybe call them out in the commit message and how they work. But maybe that is also in the code. So we're not going to just say we incremented a variable. Everyone can see that by looking at the code. We always use present tense. Is this what you wanted to?
Yes.
Okay. So all
Imperative mood.
imperative is fine.
Present tense, but
Yep.
imperative mood is.
We want this because commits are living. Anyone that's on this commit is currently on this commit. If they go back to a previous commit, they're on that one. It lives. They're all living at all times. They didn't happen in the past. They were committed in the past, but the code is living. So we want to keep with the present, because otherwise it seems we don't know where we are in time. The moving through time is what we're going to do with checkout, but not with our language. So people have called out these commit messages like this to me in the past, companies I've worked at, saying they're time consuming. Some commits are trivial. Emoji is divisive. Sure, the emoji can be divisive. You know, if you're doing a cleanup, do you use a bathtub or a shower? What? A broom? Yeah. But and they can be time consuming, but look at the things that we're getting from that time. We're getting documentation. We're getting faster archaeology. We're getting hopefully faster code reviews because we've written down what our intent is. So the person reviewing the code can know, well, you did this, but it doesn't really belong in this commit. And this is really all subject to until it's gone syndrome. If you haven't worked in a repository like this, you don't know what you're missing. I now know when I go to a repository that doesn't have this kind of stuff, I know just what I'm missing, and it sucks. And I know there's a handful of people, I think they're all over here, that I've worked with in the past. And I imagine they all agree with me on this. On the subject of trivial commits, if it's really that trivial, fine, just make it a one line. Like there's no, you know, we're not going to be dogmatic here, but this is, it's so beneficial that if you haven't done it and you start doing it, your team is going to love it probably within 3 months.
Question.
Yes.
Do you standardize the emojis you use, or you let the developer their mood select them?
I do like to have a standard set. And so I had a link here.
There's a canonical standard.
Yeah, I was gonna say that.
Emoji.dev.
Yeah, there you go.
Better than the tiny URL.
But that's not the one that I like.
Okay, sure.
This is so there are some standard sets. There's a a variety of standard sets.
You're not even using emojis. Look at this, colon, ART, colon.
It's true, it's not
Yes,
emoji.
it's true.
It's only an emoji if you render it, and
Yeah.
this code is only like 20 years old.
Yeah, I know.
Sorry to be technical.
Ooh, white check mark, that takes up like most of it.
Yeah, what if your emoji name is like 15 characters?
Oh, yeah, construction worker. Yeah, that's a pretty brutal one.
Closed
You
lock
can
with
certainly
key.
use, if you have UTF-8 in all your schools, go for it.
And your whole team does, and you're sure that everyone else who ever joins.
Who doesn't?
Who doesn't have UTF-8?
There's a lot of schools that don't.
Yeah.
Yeah, so really unfortunate.
I'm going to only use the longest ones I can find. That'll be my go-to.
Doesn't mean one versus two character with encoding terribly well.
So something that I neglected to mention in these slides is using git pull. So if you use git pull, you're going to potentially cause a mess because you might create merge commits when you do the pull. So I suggest that you change your git config to do --ff only for fast forward only, so that when you do a git pull, you're guaranteed that it's a fast forward merge. If you are doing when you can't do a fast forward merge, you can do a fetch and then a reset, and that's probably what you want. So I didn't include those slides, and I realized that halfway through the presentation, so sorry about that. Yeah.
Is there a safer alternative to git pull?
Yes, fetch and reset.
Well,
You can
And
do pull
rebates.
rebates too.
Yeah, you can do pull rebates.
Yeah.
You can also configure it to do rebates.
He changed the page where it
Yeah, so fast forward merge means that the things that you are merging can be applied directly on top of your branch. You can just fast forward right to the top of that without any merges. If you, let's say you created a commit and then you do a pull, now it's going to have to create a merge commit. And so that's also going to be a write merge, and those are the things that we're trying to avoid with that fast forward only.
Are the right merges really that bad if you squash going back?
No, if you're going to squash it going back, no.
It becomes invisible.
Yeah.
But while that branch is out, if anybody's looking at it.
You might have weird
That's-
conflicts.
you get it. I can-
That's why you just push more.
So it wouldn't be 2026 if we didn't talk about some kind of LLM. So you can actually use commit messages as prompts.
Huh.
Yeah, it's pretty fun. So let's try it out. So this repository, like I said earlier, is old.
But it's got 2 commits just today.
you can do at curly brace, you close curly brace.
Sure. So we can see that this was last committed to in 2022. And I cloned this repository and I can't build it because the compilers have moved on and they're catching new things. So we can just,
One of the warnings is errors or?
yep, there are some warnings as errors. Mhm.
Switch to open.
Yeah, I haven't switched. But let's do accept edits on. So And now this is a clean repository. There's nothing in here. There's CMake. It builds using CMake. I haven't run CMake. This is just a clean repository.
You did not manually run a net just now, right?
Nope,
Okay.
I haven't manually run anything. So now it's asking me if I want to run CMake. And so I like to do this because I get my commit message that I want. And hopefully Claude is limited to doing what I asked it to do. Hopefully.
Side question. Is it just me, or does everyone CD into their build directory before running CMake? Does no one do what I do and just run CMake-C build?
Yes, I don't, but
I-
apparently,
All the training.
but apparently enough people
That's
do
what's on Stack
that,
Overflow.
that Claude also does.
I
But you see, it
the
found
habit of
some,
CDing and
it found some shadowing.
Yeah.
It found some sign conversions.
I'm not
And this is
saying it's
just what
smart.
the
Muscle
compilers
memory,
reported,
right?
and so now it's going through and fixing them.
Wait, is it going to update the name of the project to Mavity? Am I the only one?
Where did that happen?
No, I asked if it was going to. You got it.
I do, but I'm trying so hard to remember what it's from.
It's from Doctor Who like 3 seasons
Okay,
ago.
yeah.
Accidentally changes the word of gravity to Mavity.
Remove that from my phone.
No, what? Come on. Uncultured people in the room. It's the one immediately after the female doctor, whatever his name is. I don't know. I don't know. 2 seasons ago? 2 seasons ago? 2 seasons ago.
But
Not the
I
current
also don't
season.
believe that like 2 years have passed. I don't know. It's not good.
It's not the current season. I think it's the previous season.
So it's been approximately 2 minutes.
Things are happening.
The problem is when you send Claude on a task, how often do you work on something else and how often do you just watch it? That's my problem. Yeah, watching the
I rarely watch it.
I often watch.
I might see plus weekly.
And that is a perfect way to parallelize your.
So now we got this commit. It's basically exactly what I asked it for.
Co-authored.
Yeah, Edward says it's called.
Yeah, it loves to do that.
You can change that in the settings.
Yep,
Yeah.
it's changeable. And then,
I mean, to be fair, it did author it.
and here's the things that it did. These are pretty minor. We probably could have done them in 2 minutes, to John's point. So it was in these first few, it was shadowing.
Oh.
Uh,
But then you didn't get a clang tidy warning
Yeah, like,
identifier is
it
too
made-
short.
It would have caused a problem the other way.
I have it on, but I have some exclusions.
And then in the last one, it fixed a sign.
Expensive time-wise?
It's like the most.
Oh, is that why my cling tidy is so slow? Okay, sorry.
Those identifier things are the most expensive thing tidy by far.
Huh. Huh. Make a note. real
Sorry
quick.
to rant.
So this is something that I've been playing with. And it's been useful on things a lot larger than this.
So question.
Yes.
So you basically write your Git commit before doing anything and just gave it to Cloud, right? That's what my understanding. So you, just like your standard was describe the problem and suggest the solution, that you basically do that in that format.
Yep.
And then the Cloud did it this way.
And sometimes I don't know the solution.
Yeah.
So you can also, I didn't do it here, but I do it plenty. I say, and add any notes that are needed. And I'll just give it the problem. and then it will add the solution for me. So that's what I have for the day.
Can I make an addendum about force push?
Yeah.
So the problem with force push is twofold. Right? Only two? There's two basic problems with force push. One of them is that if you successfully force push up the remote and someone else has a copy of the branch, then they will be out of sync with the remote and you can't mess and save things. Right? And that, there's no fix for that I know of other than coordination and explaining what you do. The other problem with force push, though, is that there can be changes on the remote that you don't know about. And if you force push blindly, you can actually just stomp on them. So to guard against that, you can use the parameter dash force release, which was mentioned earlier.
But there's another one too.
Will it will block your push if there are changes on the remote that you don't know about. But if you have done a get fetch, or if your IDE has done a get fetch in the background, and you do a force with release, you do that, it will still stomp on them. Because you know about them, so it assumes you must have intended stuff. So there's an additional flag you can pass along with force release called force that includes that will check that for you. So I have an alias that I use in this situation. I call it push F, and it does all those flags. I wanted to clear that.
You force push often enough and you get it.
When I have force push 10 times.
I would. Do you have an opinion on using the command line versus using automatic things like your IDE versus GUIs?
Claude.
I use the command line, but that's because I also use the command line editor.
Use my Git?
No, I just use the command line.
The same. Occasionally.
That's one of those. Okay. I think it's better, I like to go to the VS Code, he doesn't abstract as much weight.
You can change your default pull behavior. Can you also change your default push behavior?
Yes.
So that all force pushes automatically become like the Uber safe third one you mentioned?
Yeah.
Yes, you can modify everything. Yeah.
Okay.
Yeah.
Yeah. Do you have any experience in Jiu-Jitsu?
Yeah, I do. Why?
Do you have opinions?
No, the tool, not
Tool, not the.
the
tool.
Oh, no. just the push part. I was like, that's a strange question, but yeah.
Have you ever stacked this? I think in recent years it's been like a big thing. You know what those are? Can you explain?
I've only recently been using Graphite a little bit to do stack commits. And I've really only been interacting with someone else who's using it. I haven't been making them myself. So he's using it to create a stack of commits that are part of a larger pull request where, well, they're kind of stacked pull requests where each pull request requires the previous one in the stack to have been pulled prior to pulling the next one. Do you have more about that?
I was more wondering, like, what does it use under the hood? Like, does it use Squash? Does it use, or is it completely?
I don't think it uses anything under the hood other than merge.
Okay.
But I think it's doing a fast forward merge without a merge commit. Well, actually with GitHub, you can do it either way. You can do it with or without a merge commit. And I'm doing it on GitHub. He's using Graphite and I've been the one, I've merged some of them and I've approved others and watched him merge them. So, yeah.
You can also, if you're interested in the, since we talked about both jujitsu and graphite, if you're interested in the stack branch workflow, as of very recent Git, I can't remember, I think past like 6 months, there's update reps on Rebase, which will bring along, like if you go to the end of your stack, it'll bring along the rest of the stack with you. If you Google like Git Rebase update reps, there's a couple decent blog posts about it.
I've read about it. I haven't touched it.
Yeah, it's like stacked branch. I've used both graphite and jujitsu a limited amount, and I haven't been terribly impressed with them. Especially as someone who's CLI first, I got the sense that, especially graphite, if you're willing to click around in a GUI, maybe it's better. But I didn't want to touch a mouse.
What's the benefit? Is it like for coordination with larger teams, or is it?
There are, so depending on your team culture, there can be pull requests that will be outstanding for a long time. And if you have work that then builds on top of that, I think the deepest I've ever been was like 8 pull requests deep, all stacked up. And like the more that you have, then like one of them merges and now you have to go rebase all the rest of them so that one is included. Like that's a lot of toil. And so like it ostensibly removes all of that, but like it breaks the kind of fundamental model of Git so much that it doesn't feel like you're using Git anymore. It feels like you're using another tool.
That's my experience. I haven't really liked it.
Yeah.
But I do see it as a way to mitigate some of those rebase issues.
Who's the one that really missed on Gary?
And I think that graphite was just acquired.
Yeah, my cursor.
Yeah.
Oh, really?
And
Probably.
I'm not sure. I'm not sure what's going to happen with the project.
Have you used it recently? Because I used graphite. I got like one of their very early beta.
Yeah, I like on open source stuff. I get people that use it. I'm like, what's it for? And yeah, I'm mostly just curious. Like, I didn't know if it was like kind of solving some of the problems that you talked about.
So
if you have deeply stacked branches and you do that a lot, and at least in the beta you don't mind using a GUI, it seems fine. I don't know if they fix their CLI.
Fixing. The issue is like, why do you have stacked?
Yeah, it's
Well,
a
so
technology problem solving a culture.
Yeah. So our use case.
Or technology solution solving a cultural problem.
Yeah. So
PR's not moving fast enough.
Well, our use case is specifically that PRs aren't moving fast enough, but it's because we like to make sure that it gets tested in a live environment before it gets merged, which can really slow things down. So, we will have, some commit that the author is comfortable running in a live environment, but it hasn't been reviewed yet and might take a day or two to get reviewed. And by that time, he's pushed 3 more things on top of it that are independent but require the first one. And he wants those to get reviewed as soon as possible. He doesn't want to wait while those continue to stack. He doesn't want to wait for reviews while they continue to stack. So it's a problem. So it is a cultural problem. If we had a testing environment that we were more confident in, then we wouldn't have the problem. But we're interacting with an API that has weak documentation at best. So our interaction with the API, we think that things are going to be okay. And then sometimes when we're using corners of it, it breaks in weird ways. So we're required to do this like live test. And it's this, so it becomes a vicious cycle and it really slows us down. And we don't know how to make a test environment for it. So.
What do you mean by live tests?
By live test, I mean run in production.
Well, how can you run a production in non-developed branch? Or I mean, do you basically your feature branch is distributed to users? Or?
Sort of an A/B test.
Okay.
Our situation is unique. Like everyone is their own delicate flower, right? And
Jason, do you have anything to say about that?
So we actually have a large set of live environments. And what we will do is carve off and run it on one part of the live environment, which has a very limited interaction set. So like an A/B test, where maybe 1/100th of the traffic is getting to that live thing. Or someone can actually be there to babysit. So
Doesn't that happen before code review?
it often does, yeah.
That's possible.
Yeah, what's that? Oh, sorry.
I said if the test passed, that's the definition of shippable, right?
Right, yeah, yeah. But we may not want to send it to the rest of the environment without running it live on a very small thing. So that we have better confidence that we don't have a really large outage. Yeah.
Have you used work trees at all?
I have not used work trees. I used to use a similar thing in a version control system called Bazaar. But I can talk about the idea of them, and maybe someone can
I
correct me.
use them extensively.
Great. Why don't you talk about them?
What do you want to know?
I could use them, they seem to be a good alternative to stash, and for everything sort of stashing stuff and using else.
So the mental model that I would encourage you to use for work trees is if there's ever a case where you have a second clone of the same repo on the same system, you should not be doing that. You should never do that. You should only use a work tree instead. It saves you from the whole raft of problems there. Like you check out the same branch in both clones, and then you like commit to it in both of them. Like now you have a giant headache. Work trees will just not let you do that. You can have it in one place or the other. You can't have it in both. It allows you to do things like I will often have like an underlying branch where I'm working on my refactors, and then like an overarching branch where I'm doing the actual feature work. And when I notice some annoying thing, I'll switch to the underlying branch, which is in a separate work tree, go do that work, and then kick the build off, let it test, and go back to doing like actual real work. And then I'll just like rebase right on top of that once I'm satisfied with it. So you can have multiple pieces of work in flight. If you have a like I used to work in embedded systems, and there's like hardware availability problems there. And so if you have like a slow build, or like you won't have access to the hardware until tomorrow or whatever, do it on your work tree, build it, get it all ready, and then go do something else. And all your build artifacts are still warm on the other one. You don't shoot them in the face by going and working on something else. Like all of that set of problems, like think work trees.
So in this diagram, am I right that the working directory is replicated?
You have you have a full replication of the working directory and the staging area. There's only one .git directory for the entire cluster
So
of
it's
work trees.
the repository part of it is
Yes.
shared. The staging area and working directory are replicated. So you have a bunch of for each work tree. So for each work tree, you have your own working directory.
And that's visible like the file system, so like if you have an LLM, you want to.
That is the file system, yeah.
The cursor uses work tree to run.
That's kind of crazy. Yeah, or if you find out like, oh, there's a production fire, right? Like I always have a work tree that's just clean main. Like there's a production fire, great. Like I'm gonna go start poking at clean main. I don't have to throw anything away. And then when I'm, ready to go back, that like everything is right where I left it. I don't have to reestablish anything.
What was the comment?
Yeah, I almost never stash. The only time I really ever stash is when I like write something and then the tests are all of a sudden failing and I'm like, wait, were they failing before this, or is this what did it?
That's when I use stash also.
Yeah, like
There is an online comment, sorry. I had from Leslie. I had used worktree before when doing major rewriting while still trying to maintain and modify the main branch.
Yeah.
Michael.
I was gonna go back to the stack.
Okay, well, we'll go back to it.
What's your opinion of submodels?
Ooh.
Yeah.
There are no case solutions in electric package.
Yeah, fine, it's a second-class citizen at best. It's an unfortunate reality in our C++ world. In other languages that have package management, I would try to avoid them. You can also do some work to avoid them by using a package management system in C++, although those kind of suck too. So
Choice between submodules and Conan. I would take submodules.
yeah,
would
that's
choose
always
CPM.
where I've landed. I've always landed on submodules instead of Conan.
Yeah. No, CPM instead of Conan or submodules.
Yeah.
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 If you want to use another project, then submodules are.
Yeah.
So some modules in like the super repo workflow where like you have like a large distributed system that you want to like track your release cuts for are reasonable, but like beyond there.
One suggestion with Conan, if sub-modules, people should look at Conan workspaces. If you want to use Conan as a sub-module replacement.
Oh.
And if you want to maintain the the packages, or you want to make changes to the sub-package.
So, Michael?
I was gonna say, no, whether this is a cultural problem or it's subjective, I think, but the other place I've seen stack MRs and pull requests used is when you have a lot of small changes that are in commit but related and require each other. Like somebody moving really fast, they're knocking out these small stacking related changes, and maybe they have 3 or 4 pull requests stacked for lunch, and everyone else is working on their stuff and open for pull requests,
Well, I think why Brian called that a cultural problem is because ideally it would get reviewed and merged, especially if it's small, very fast. But, we have, the reality is CI pipelines can be long. Our coworkers are busy. So calling it a problem, it is a problem compared to the ideal state, but whether there's something to be fixed or not, I don't know.
I just wanted to put out a small tip that I alias cherry picked to CP for 2 reasons. 1, it's what it does. It copies commits. 2, cherry pick is the worst command for autocomplete.
Because there's
Yeah.
because there's hash. No, because there's cherry.
There's cherry,
Yeah.
nobody uses ever.
Except
I think
unless
it's
you tell
good
me what
cherry.
it does,
Yeah.
I will buy your drink.
Right.
And what that means, especially in
Dirty commits.
yeah, I've seen.
Oh, and submodules.
With dash dirty appended to the end.
Yes.
Oh, with submodules. Oh, yeah.
If you modify a file that lives in that submodule, then that submodule is dirty.
Yeah. So when you make a commit and the submodules are modified from what they're supposed to be, then the commit is not the commit that you think it is. So because you potentially tested that commit and it's not, it's based on a different version of the submodule. Does that make sense? Okay, let me back up a little bit. With submodules, there's a list. I don't remember where this lives because I don't really use submodules Yeah, it's modules.
And it also lives in other lists.
Yeah, it's kind of confusing. It's spread around a little bit.
What's a dirty working tree?
Yeah, okay. So it's, so there's a list in your repository of the hash of every submodule and where the submodule came from. So where it got cloned from. If you modify any of these things, if you modify what commit is in the submodule, or you change where it comes from, or you change a file in the submodule, but you don't commit it, then the hash of the submodule that's in your repository doesn't match the current hash of either the submodule, like repository state, or it's not clean, so it wouldn't if it was committed, then it's dirty. And by dirty, Brian's asking what dirty means, it means that there is something that is modified somewhere in the repository that's not committed. Now, it could be an additional file, it could be, or it could be a changed file, or a deleted file. So I think all it means is that you committed something with your submodules not being what they're supposed to be, and what they're supposed to be is subjective, but it doesn't treat it as such.
Is whatever was on that commit before you changed it.
Yeah.
I mean, there's a commit hash that it points to, and it's like, this is the commit hash that you're committing with, but it's not the one that you were running with because you changed something.
Yeah,
Yeah.
you got some changes, you have something in your working directory that was not committed. I think.
In the working directory of the submodule.
Yeah, I think if you do a git describe on your main repo, when you have like anything in your staging area or working directory, it will also say that the commit of your main repo is dirty.
Mhm.
I think some of the context is that if you were to share the code that you were running, but the something is dirty, you do that. Made some modification, they would get well by cache.
Because they wouldn't get like future input.
Yeah, they wouldn't get that uncommitted change.
It's the same as if you only added some of your changes in your repo though, and then committed those half of them.
And sharing that. A little more.
Yeah, it gets caused because submodules is this not quite second-class citizen.
What is your strong opinion of the emoji clause here?
Oh, yeah, I don't like that one. But, yeah, I haven't disabled it in that repository, so. Yeah, it's about time for Michael to buy drinks.
Yeah, apparently it's 4:00. All right.
Well, thanks.
Thank you, Lenny.
And I hope this is useful.